Okay. So I have written down all the important topics that we have covered so far. Okay. So if you let me just remind you, we are going across with OSPF. So we covered the introduction, we covered OSPF packet type, we covered OSPF hello packet components, the router ID, the 7-state neighborship of OSPF, the designated router and backup designated router, OSPF configurations, the passive interfaces, requirement for neighbor agency, under advanced OSPF we covered network types, type of OSPF LSA, and area type. And under area type, as far as I remember, I had demonstrated the stub area and it was pending with not so stubby area. So I'll continue with whatever topic that was left over in the previous class. Okay, fine. So as far as I remember, we were discussing the advanced OSPF. So under advanced OSPF, we have OSPF network type. So under OSPF network type, we have various network types like broadcast, point to point, point to multi-point broadcast, point to multi-point non-broadcast, and non-broadcast. Okay, and loopback. So this was discussed. Then types of LSA, link state advertisement. So under link state advertisement, we covered router LSA type 1, which is intra area. That's nothing but within the area. The link state advertisement or the LSA packet which uh, origin within an area. Okay, so you will see this type 1 only within a single area. You will not see area 40 LSA type 1 coming to area 0 or vice versa. Similar way, network LSA, which is called as type 2, and if you have DR in your multi-access network, then DR is going to emit these kind of LSAs. You have the third LSA type, which is called as network summary LSA, which is which is seen when you have multi-area networks. So let's say I have two areas, area 0 and area 40. So these routes would come to area 0 and you will see the routes or the networks from area 0 going to area 40. And who is taking care of that? It's taken care by ABR, which is called as area border router. So ABR will emit these types of LSA, type 3 LSA. So this network will be advertised over here and this network will be advertised on other areas. Okay, and then we discussed about type 4 and type 5, which is with respective to external routes. So let's say when I have OSPF, okay, multiple OSPF areas, and also I have an external routing protocol, let's say EIGRP. So these external routes, if you need to advertise within OSPF, so they take up the LSA type 5. Okay, so from, let's say, from this area point of view, to reach external route there must be some gateway. Okay, so who is going to point to this ASPR? So this act as a ASPR, autonomous border router, and over here you have ABRs, area border router. So LSA4 is emitted by ASPR, so it's acting as a gateway. So basically from this OSPF area, if you want to reach to EIGRP, who will do the work or who is going to take care of your packet? So it's your ASBR router. So ASBR act as a gateway. Okay. So type 5 is those external routes and type 4 is your ASBR which act as a gateway. Okay, originated by ASBR type 4. Type 5 is also originated by ASBR. It's more of your external routes. So let's say you have couple of routes, and if you need those routes to be advertised within OSPF, then you need to allow the type 5 LSA. The last one here was not non so stubby area, type 7. Who originates this? So it's your ASBR. Why do we need NSA? So let's say I have EIGRP. Okay, I have EIGRP. For some reason, I just want to take out those LSA 5. I just don't want any external routing protocol on this area 1. So in case I enable stub, all my external routes are going to be discarded. So there is no way those external routes can get into area 0 or area 2. Let's assume area 2 still wanted external routes. Okay, there were users who wanted the external route, but since you made this area 1 on stub, all your external routes are getting blocked. Okay, so to overcome such scenarios, instead of making it as stub, I would rather make it as non so stubby area. So what non so stubby area does is it's going to convert all LSA 5 to a special LSA called LSA 7. Okay, so there will be no LSA 5. Instead of LSA 5, there would be a new LSA which is called as LSA 7. Okay, now this LSA 7 will convert all those 5 LSA 5 into LSA 7 and then take it over to ABR. Now ABR will reconvert from 7 to 5, and you can see LSA 5 here. You can also see LSA 5 here. Okay, so this is how your non so stubby is going to help you. If you would have made it stub, then there is no way the LSA 5 would have advertised. Okay, so that would have been drawback of stub. Let's say I create stub here, then there is no LSA 5, neither there is LSA 5 here. Okay, so instead of making it stub, I am going with not so stubby area. Now what happens? The 5 will get replaced with 7. Okay, so once this LSA 7 travels to ABR, ABR will reconvert back to 5. Okay, and that's how your external routes will be forwarded. So this is a work of NSA. It's going to suppress LSA 5 here. Okay, we will do this lab and we will check this. Okay, area types. We have backbone area, so always area 0 is considered to be backbone area. The standard areas are between area 1 and the maximum that's possible I have written in the decimal format. So as we know about stub area, stub is a concept where you are blocking the external route advertisement, okay, which will improve your size of database. What are the LSA that stub is going to support? It's going to support 1, 2, 3 and a default route. So we have seen this in the previous lab. As soon as I create stub, all my external routes will start pointing to a gateway. Okay, so that's the default behavior of stub. The next version of stub is called as total stubby area. So we can do this over lab and I'll show you. Okay, so let's say I have my GNS here, so which is the stub here. So I was making use of the Roam router as stub. Okay, so when I make this router as stub, all my external routes get the type 5 LSA will get blocked by keeping a gateway, default gateway on this IP 0.0.0. Okay, so let's check that. So I go to my console on Roam. Okay, so let me check if I have enabled stub or not. Okay, I do not have stub, so let me make it stub. area 80 stub. Okay, so once I make stub on one side, let's say I have just made the stub over on this side. Now they will lose the adjacency because of different area type. Now this is one of the criteria. So I'll go back and on Mumbai router 2, I'll make it as stub on this interface. So I'll go to Mumbai router 2. Okay, I'll make use of area 80 stub. So once the area matches up, they will come back. Okay, so I can see that with the command IP OSPF neighbor. So I can see the neighborship now. Fine. So what has happened? So what has happened now? So let's check it out. So you will see there is LSA1, LSA2 and LSA3. Okay. Now where is LSA5? So there is no LSA5. So how is these external routes being taken care? So it's been taken care by injecting a default route in inside the RIB, routing information base. Okay. So this default route will be placed. Now, as I was talking about the next area, which is called as totally stub area. Now, what is totally stub is going to do? So let's say when I check the database, I also have type 3 LSA, which is called as summary LSA. Now, with the help of totally stub area, I can also block those type 3 LSAs. Okay. So I just need to add one extra keyword. So let's try out that. Okay. So over here, I say no summary. I go back to the Mumbai router and I do the same command, no summary. So let's see what happens now. So if I open up the database, so you will see now lot of summary database have been reduced. See, you have LSA1, you have LSA2, and what has happened to LSA3 is they have injected a default route. Now there is no individual link vectors, or there are no individual links in the inside LSA3. Okay, it has been reduced to just a single gateway. Now this is what happens when you bring totally stub area. Fine. So this was regards to stub. Now to check the behavior of non-so stubby area. So let me tell you the requirement. So let's say this is external routing or external routes. So in our example, this is EIGRP. Okay. So these networks are being redistributed over here. So this router is acting as a redistributed. Well, so let's assume I want to block my external routes. So if I make use of stub, so what's going to happen? All my external routes are going to get taken down by injecting one default gateway. Now let's say I wanted external routes over here, okay, which is behind area 0. Now since you have made already stub, so there is no way the external routes can reach here. So I cannot make use of stub in such scenarios. Okay, but yes, I have to take care of my LSA5. I just want to block LSA5 because I don't have any user here who wants to communicate with EIGRP users. So I don't need LSA5. So how can I achieve that? With the help of non-so stubby area. So when I do non-so stubby area, the other factors, the other things will still remain as it is. Okay, this non-so stubby area is just going to be reducing the LSS only on this area. It's not going to impact any other area. Other area will still work the normal way. Okay, so let's bring in this non-so stubby area concept. So I'll go to Mumbai 6 and Mumbai 4 where I need to configure non-source stubby area. So I say router OSPF1 area 40 non-source stubby area. Okay, so on the other side, it will come down, the OSPF will come down because of two different area types. So on the other side I have Mumbai 6. Okay, so looks like it was already configured. Okay, so I'll just remove this. Okay, so see, this is what happens when the NSA on both side don't match, then the agency is going to go down. So I'll bring up NSSA, and on other side, let's see where am I running the OSPF. So I have OSPF on process number 1. I say area 40 NSSA. That's nothing but I'm configuring non-source stubby area over here. Okay, the rest of the routers are turned off, so we don't need to do anything, and this is a layer 2 switch, so I don't have to do anything. So I'll configure non-source stubby area here, and I will configure non-source stubby area over here. Okay, so let's see the LSAs now on these. So show IP OSPF database. So do you see do you see an extra LSA now called as type 7? So basically these are the new LSAs that's getting originated. Okay. So your autonomous border router is going to originate type 7 LSA. So there will be no type 5 LSA. Okay. There will be no type 5. So let's see the routing table. So if you see the routing table, there is no so there is no impact. Okay, there is no impact. We still have the routes 113 and 114, which is nothing but facing towards EIGRP. Okay, so you have this, which is local, and you have this, which is learned over EIGRP. And when you open up the database, you will see there is no type 5. Okay, so we can verify this with the help of Wireshark. Do Okay, so regarding the type 7 LSA, so if you see now, when you have enabled the non-source stubby area over here, so you will see a new type 7 coming in. Okay, so what are the behavior of non-source stubby area? So there are something called as N and E bit. Okay, N is nothing but when you turn on the NSSA properties, and E is when you are suppressing the external routes. Okay, so I'll show you this with the help of Wireshark. So if you see now, it says it's NSSA supported, and at the same time the external routes are being turned down. Okay, so there is no LSA 5 now. It's just NSA. So now what happens in this scenario? What happens? So let's say you were receiving the external routes, okay, and then you just took down those LSA 5 and you just got a new LSA called as LSA 7. Now, how is this LSA 7 treated by ABR, Area Border Router? So, how is ABR going to treat LSA 7? Or how is those external routes going to get advertised here and advertised here? So, basically, this ABR will translate back. So, the work of this ABR is to translate. So, all LSA 7 will now get translated to LSA 5. Okay, and then it comes over here, and this is, since this is a ABR between area 0 and area 80, so basically it will also advertise LSA 5 here. Okay, now it depends on you. If you have kept stub, you still have LSA 5 coming over here. Okay, so basically you're going to have the end to end reachability. So let me show you what happens here. So when I go to the fourth router, which is between area 0 and area 40, so let me show you the translations. Okay, show IP OSPF, show IP OSPF database non-source stubby area external. So what is happening here is your translations are happening. Okay, 7 to 5 translation. Who is translating or who is advertising those type 7? It's your 6.6.6, which is nothing but your redistributed router. Okay, the router which is doing care of redistribution between EIGRP and OSPF. And let's see the LSA database on one of the router within area 0. So the normal behavior, you still have type 5 LSA, and if you open up the roam router, so over here you have enabled stub, right? Yes, you have enabled stub with no summary. So do I have reachability to my external route? So let's ping that. Okay, I'll take this IP, I'll try to ping. So it's reachable. Let's do a trace route. So it went through this IP dot one, which is this, and then it went to 2314, that's over here, then 10 dot the 11 sorry 100.3, which is here, and then onto the EIGRP gateway. So this was the path. And what are the network types that you are seeing right now? You have NSSA over here, you have your backbone area over here, and you have your stub over here. Okay, what is non-so stub uh, helping us with? It's just stopping all the LSA 5 by creating a new LSA called LSA 7. Okay, so let me show you once again. So you see there is no type 5. Okay, so you have type 1, you have type 2, type 3, and type 7. And let's see the routes. Okay, so if you see the routes, Okay, so let's see the routes over on Mumbai 4. So you can see the two routes here with the tag of N2. N2 is nothing but now non-so stubby learnt routes. OSPF NSSA external type 1 and OSPF NSSA external type 2. Okay. Now this is not called as E1 and E2. It's called as NSSA routes, non-so stubby routes. And then this router, which is acting as ABR, this will translate all the type 7 to 5. Okay. And that's how your OSPF, the OSPF backbone will know about all the external routes that's been advertised. Okay. And then these routes can be advertised to any other area. So let's say in this case I have only one area, so I receive the external route. Since I have made this as stub, I'm still suppressing all those external routes. If I take down those stub, I can bring up those external routes. Okay, so let's go to configuration T. Let's go to router OSPF1. Let's say no stub, no area 80 stub, and the same commands go to the second router OSPF1 no area 80 stub. Okay, so now they are not in stub. So let's see the external routes. I guess the process is 100. Okay, so this is not 1, this was 100 process, and I'm going to remove this. Do show run session OSPF. So what do I have on the interface? Okay, and over here okay, and what is the process? Okay, okay, so the OSPF has come up. So let's see the routes now. So you see here the routes are still being learned, okay, with E2 routes. So that's how your different OSPF area types comes into picture. Okay, and what is N bit and E bit in the case of NSA? So N, let's say if N equals to 1, N equals to 1 with E equals to 0. Now this says that NSSA is been active. Okay, if N equals to 0 and E equals to 1, so that means this is a stub area, or there is a external routes. So what is N bit? N is nothing but non-so stubby area supported. What is E? External routing is supported. If you see E equals to 1, That's nothing but when you have the external routes advertised. Okay, so that's about these two bits. Now what is this point says? When the peer exchange hello message, so when I have two routers, so when I have two routers, okay, as I told you, if you enable NSSA on one side, make sure you also have the NSSA on the other side. The reason is your hello packet is going to carry the E bit. Okay, so it's going to carry the N bit. Okay, so it's going to carry this N bit. Now let's say you don't have the configuration on R2. Now the hello packet over here will be n equals to 0. Now on one side you have n equals to 1 and on other side you have n equals to 0. Now that's going to not bring up the adjacency. Okay, so I have also showed you this over on Wireshark. So when you have NSSS active, so you will see the bit with number 1. Okay, so that says you have this enabled. Make sure you enable this on both the side, otherwise you will lose your OSPF adjacency. What is this going to say? So who is going to translate type 7 to type 5? It's your ABR. Okay, and the ABR will flood all the external routes inside the OSPF topology. In our scenario, these were NSSA LSA 7. Okay, now who is converting 7 to 5? It's your ABR. Okay, so the LSA 7 gets converted back to LSA 5 by the ABR. So basically it's going to bring up all the external routes like 113 and the loopback 114. So you can see 113, 114 over here. Okay, regarding the translations, okay, which is part of P bit. So when you enable 7 to 5 translations, your P bit will be set to 1. Okay. So let's say when you're converting from 7 to 5, your P bit will be set to 1. If you don't translate, that means if you're not going to translate from 7 to 5, now the P bit will be set to 0. Okay. If no type 7 to 5 translation, that means P bit is 0. So what is P bit used for? It's used to tell the ABR whether to translate or not. Okay. So over on my network diagram on ABR, I'm gonna send a P bit. Okay. If I set P bit equals to 1, that means the ABR has to translate from 7 to 5. If I don't do that, if I send a P bit equals to 0, that means 7 will not get translated to 5. Okay. And how do we see that whether it's getting translated or not getting translated? So I just showed you on the router Mumbai 4. If I do show IP OSPF non-source stubby, okay, show IP OSPF database non-source stubby external, so you can see that ABR is in a translation mode. Okay, so this is called as translation. It's translating to the upwards direction. Who is doing that, or who from where are you receiving this? So you're receiving those NSA LSS from this router, and this router is nothing but this one, the distribution router, where which is connecting between EIGRP on one side and on other side you have OSPF configured. Okay, so that was regards to NSSA. Okay, now there is one more area type which is called as totally non-so stubby area. Okay, so if you remember, in the case of stub and totally stub, I was blocking LSA 5 here, okay, by injecting 0.0.0. In the case of totally stub, I was blocking LSA 5 as well as LSA 3. Okay. Similar way, in the case of LSA, in the case of non-so stubby area, I'm blocking LSA 5. Okay. Now in case I want to block LSA 3, I need to make use of totally non-so stubby area. So when I make use of totally non-so stubby area, I'm blocking LSA 5 and as well as LSA 3. Okay. So there will be no LSA 3 and there will be no LSA 5. So that's a work of totally non-so stubby area. So what is 5? It's the external routing capabilities. What is LSA 3? These are the summary routes between inter area. So when I have two areas, area 0 and area 10, so the router, which is called as ABR, will send LSA 3, which is nothing but summary routes. All the summary information of this area to the backbone, and the backbone will send all the summary routes to the next area. So we can suppress that. We can remove those LSs by these totally stub and totally non-so stub. So these are two additional factors. Okay, so the same thing once again I have mentioned in this chart. So in the normal areas, there are no LSA blocked. You will see all the LSA flowing. In the case of stub, you will see the LSA 5 will be blocked. Okay. In the case of totally stub, you will see there will be no LSA 3, 4, 5. Okay. So there will be a default summary route placed. In the case of non-so stubby area, you will not see LSA 5, but you will see LSA 7 that converts type 5, okay, which converts to type 5. And in the case of non-so stubby area, totally stub, or I can also say totally non-so stubby area. So over there you will block LSA 3, 4, 5. Okay, so they will be just a default route, but LSA 7 will be still working out. Okay, so these are the different types of area in OSPF. Okay, so the next topic here is path selection. Okay, so as we know, we can have a single area, or when I have multiple areas, or when I have external routings. Okay, so multiple things or multiple options can be seen in the case of OSPF. Okay, so the routes that you see within a single area is called as intra area routes. So if you see the routes over here, it's called as intra area. Now if you see the routes between area 40 and area 0, or area 40, 0 and 100, okay, so something like this. So let's say the networks were learned on all of the areas. Okay, so what is a link state vector? So basically the database will be synchronized and all the networks will be learned across. Okay, so if I see one of the route, one of the network, let's say 4.4.4.4 from area 40 over here. Now those type of areas or those types of routes are called as inter area routes. Okay, between two different areas. So when you see a network or a destination network which is advertised between two different areas, we call it as inter area. Intra is a keyword that's used when you see the network within a single area only. There is no concept of multi area. Okay, and the last one is external routes, which is nothing but the one which comes with tagging E1, E2. Okay, or N1, N2. So basically these are the external route. It could be EIGRP or BGP or RIP, any external routing protocol. Okay. So given a scenario, so let's say someone asks you that in case of OSPF, you have so and so many areas, so which would be the best one? So it goes in this way. So let's say you have intra area to be taken up, so this will win the election. So the routes learned over on intra area will be considered first. The second one would be inter area, and the third one would be external routes. Okay, when there is no intra area, when there is no inter area, then only left out is external area. So I have a diagram where I can show you this. So let's say I have this diagram. Okay, so I have area 0 here, and the rest of are in area 1. Okay, area 1. So let's say my packet can travel either in this direction to reach this network, or my packet can travel over on this direction. Okay, but the interesting fact is I have a serial link. Okay, and over here if you see, they are all a faster link. You can see the cost is 1 and 10. If you just add them up, it takes only 11 cost value to reach this. But at the same time, if you add up these two, they takes 110, or totally 110 cost to reach to the destination. So one would have already guessed it that this would be the best path. Okay, this would be the best path, and this would get installed in the routing information. But that's not true. Okay, in the case of OSPF, that's not true, because when you have intra area, prefer intra area, not inter area. In this scenario, your areas are getting changed. Your packet is going to area 0, and from area 0 it goes to area 1. Now that's inter area, right? Even though cost value is 0, but it's falling under inter area category. Whereas over here you see there is a serial link. Okay, a slower link, but they are in a single area only. You'll see they are still in only one area, and they are called as intra area. And as we know, intra area is best preferred. So in this scenario, the packet or the destination or the hops will be in this way, from R1 to R3 and R4. So the packet will flow in this direction rather than taking up the cost value. So how do we see whether it's a intra area or inter area or intra area? So let's say I'm on area 0 or a backbone router. So if I do see show IP OSPF neighbors, so these are the neighbors that I have. Okay, so let's see what is the route information. So this is a loop back. So let me see what network I have with me. Okay, so I have this network, show IP route. Okay, so let me show you for inter area first. So when I do see this command, it's a type inter area. Inter area is an example of two different areas. Okay, one area 0 and the other network on other area. So when I see the network details of my own area, the network falling to my own area. Let's take this an example. Okay, so they are acting as, say, directly connected interface. So let me take something else. Okay, so I don't have any router which is powered on. So this is off, and this is off. Okay, so let me get one of them. So let's see if I have my interface. So I don't have OSPF right now. What about interfaces? So I have interface configured. So let advertise the networks. Okay. So let me show you an example for intra area. Okay, so now you see here. So this is an example for intra area. Intra area is when you have the network within the same area. Okay. So let in this example, I'm checking out the route from this, which is R2, part of area 0. And which network am I trying to see? I'm trying to see this 7.7.7.7. So how are they learned? They are learned over on OSPF intra area. Okay. So this is called as intra area. Now what is inter area? Now let's say I have this network which is on area 40. If you read this network over on R2, now that will be shown as OSPF inter area. Okay. So as per path selection, the best path selection, this has been considered. Intra area is considered. Okay. The second one is inter area. And the third and the last one is your external routes. Okay, so let me show you the next example, that is in the case of inter area. So as I told you, inter area is when you have multiple areas. Okay. Let's say the packet is traveling from R1 to R6. So it can take up R1 to R2, R2 to R4, and then R6. Or it can still take R1 to R3, R5, and R6. So which is going to be preferred? Now both are going via inter area. Okay, so there is no need to check for intra area because there are three different areas. So this is ruled out. I need to see the metric values or the cost values. The lower the value, the best is that particular route. Okay, so the best one is always preferred based on a lower metric value. So let's calculate the metric value. So I have 10, 20, and 10, which makes it 40. And over here I have 25, 10, which is 35. So obviously it's going to take up this route. Okay, so that's how the OSPF determines the best path selection. Okay, now regarding to the equal cost multipathing. So as we know, OSPF supports equal cost. it doesn't support uh, non-equal cost. Okay, it doesn't support non-equal one, it only support equal cost. By default they are going to have four different links, or it's going to support four links as a equal cost. But with the help of this command maximum path, you can just change the process to like 32 links as well. So I'll show you one example. Okay, so let's go back to this region. So I used this earlier for EIGRP. Okay, now I'm using it to show some OSPF path selection and all those things. So as you can see, I have all the IPs listed. Nothing much done. There are only IPs listed. Okay, so as per those IPs, I have configured my devices. So if I show you the first device, show IP int brief, exclude unassigned. So you will see the IPs are configured. So you will see the same thing, the similar thing on all these routers. Show IP int brief, exclude unassigned. So you will see the IPs. So what are these IPs? So let's say this is Tokyo R10. So from Tokyo R10, I have two interface, and from the diagram you can see the two IPs are being configured. Okay, very CCNA level. So I'll go to the next router, which is 29 IP int brief section, exclude unassigned. Again two interfaces here. Now what is that interface? One is this, the other one is this. I have configured the IPs accordingly. Okay, and then I'll go to Tokyo R12. Show IP int brief, exclude unassigned. What do you see here on Tokyo R12? Two interfaces and IPs configured as per the diagram. I hope you all know how to configure IP address. Okay, so if not, so let me give you one example. Okay, so I go to interface 0/3. I say IP address 192.168.20.2 no shutdown. Okay, so this is how we configure interfaces. I have assumed that you guys are in CCNP batch, so I have done this already. Okay, because I don't want to spend timing configuring these interfaces every time on these many routers during the classes. Okay, so I assume it's been I assume that you guys know that. If you do not know, just ping me one to one and I'll take care of these few things in the next class. Okay, I'll probably do this in the live class, so that's going to be little lengthier than the normal. So those that would actually increase the duration of the class. We would not be winding up in as per the prescribed time. So that's why I do this interface configurations. Okay, now going towards the last router, which is Tokyo 30. That is this one. So it has three interface. Okay, E0/0, E0/2, and E0/3. Show IP int brief, exclude unassigned. So you have 0/0, 0/2, 0/3, and for testing the packet flow, I have created a loopback address. Okay, so you can just assume it in this way, that loopback is behind this router. Okay, so one of the network behind this, which is 10.10.10.1. Okay, so when I initiate some ping, I can see my packet traveling in this way. Well, so these were interface configuration. Now I need to power on OSPF process. Very similar thing which we've been doing so far. So let me show you the configuration of OSPF. I have enabled process 1 and I have enabled all the IPs. So basically 0.0.0 with the wildcard of all 255 says that I have enabled OSPF process for entire IP ranges. Okay, that's not a best practice, but yes, in the lab environment, I can I can do this configuration. Or what would be the best practice was, so I would have gone individually to each network and advertised it. So let's say this is one of the network. I would have advertised this way. Okay, so that's just going to increase lot of unwanted uh, time over here to get up the process. Okay, so just to simplify this, what I did, I just went to the network, I enabled all of them on area 100. Okay, just a single command which will take care of all this network. So basically all this network will have OSPF running. So let me show the OSPF process on Tokyo R10. I'm having OSPF process ID 1. I have OSPF running on both the network. Okay. So in this case, I have only two network which I have powered on with this statement. Let's see the next router, show run session OSPF. So how many networks I have? I have two different networks. One is 50 and one is 40. And I'm just bringing up the OSPF process for them. Okay. Similar way, show run session OSPF. I have this command, and how many interface? So I have two interface once again. Okay. So this is Tokyo 12, which is this one. So I just showed you the OSPF on these. So let me also show on the last one. Show run section OSPF. So as you can see, the similar command easier for me to configure because we have done network, we have configured one after one. Okay, so I just assume you guys are thorough with those concepts. So just to minimize, just to make it simpler, I'm just allowing everything. Okay, so how many interfaces? So I have four interfaces. So all four are getting advertised under OSPF process. So let's see the routes now. I go back to Tokyo 7, the first router, that's this one, and I'll see the routes. So first let's see the process. Okay, so let's see OSPF neighborship. I have three neighbors. Okay, so what are the neighbors? I'm forming neighborship with this, this, and this. Okay, so this router is in neighborship with all the three. So that's a good result. Okay, I'm not missing out anything. What is my OSPF database? So since this is a single area of 100, okay. So I see type 1, I have type 2, but there are no type 3, no type 4, no type 5 because I don't have any other areas associated with this. Okay. The reason is on the other side, that is on this side, I have EIGRP which is getting redistributed. Whereas on this side, I have only advertised OSPF. I do not have any OSPF connected anywhere else. Okay. So I will not see any other kind of LSA. I will see only type 1 and type 2. Okay, now let's see the routing. So if you see the routing now, so what is that network that I wanted for my example is, let me check it over here. So that is this network. Okay, 10.10 network. So where is 10.10 network? So that is over here. Okay. So why is it taking only 2? So it's taking over on 40.1 and 20.2. Why is it not taking this way? So let's verify that. Might be some issue with my configuration, or some issue with some manipulations or something. Okay. So what I'll do is I'll see the cost value. Show IP OSPF. What is the interface here? So the interface. So how is OSPF? So how is the OSPF metric or or the cost going to get associated with the packet? It's because of the outgoing interface. Okay, not because of the incoming. It's because of the outgoing packet. So I will see what is the cost here. Show IP OSPF interface 0/1. So that says cost is 64. Okay, now that's look little abnormal to me. So to verify this, let me also check the cost value of other two interfaces. Okay, that's 0/2, 0/2 and 0/3. So let's verify that, because those two are considered as best route. So let's see what is the cost over here. Okay, so if you see, it is cost 10. So why is it showing cost 64 on the other interface? Okay, let me also check the last one, which is 0/3. And if you see, the 0/3 is also 10. That is why you have two best route placed in the routing information or the routing table. Okay, instead of 3, only 2 have been placed. So why is that third one not getting counted as a better path? Because of its higher cost value. Now why is the cost more for this? So let's verify the interface. Okay, so you have bandwidth of 1544 kilobits per second. Now what about the other interfaces? Okay, you have 10,000 and you have again 10,000. So because of these two bandwidth, the cost is getting calculated to be 10, whereas over here cost is getting calculated to be 64. Now that's interesting, right? So how is OSPF cost calculated? It's reference bandwidth divided by bandwidth. Okay, so in the case of OSPF, we consider 10 to the power 8 as reference bandwidth. And now what is the actual interface bandwidth? It's this. So if I have 1544 into kilobits per second, so that's going to give me 64 cost value. So you can make use of calculator and you can get this one. Okay, so the cost value is going to be 64. Now in the case of these two bandwidth, so let me write once again the formula: reference bandwidth divided by interface bandwidth. Reference bandwidth is 10 to the power 8, and what is the interface bandwidth? It's 10,000 into kilobits, which gives you an output of 10. Okay, so these are standardized. These are some of the popular interface medium which we can see in our PDF as well. So for an Ethernet, or let's see for serial link. So for an serial link, this is how the calculation happens. This is 10 to the power 8 divided by 154 kilobits per second. It's going to give you 64 cost value. For the Ethernet links, the reference bandwidth will be 10 to the power 8 divided by 10 Mbps, which is going to give you the cost value of 10. Okay, so in this example, the reason why the two routes were picked and not the third one is this is having cost value of 64, we have 10, we have here 10, 10, 10, and 10. So this and this act as a equal load sharing or equal cost, whereas this is out of the league, so they are not getting considered. Now how can I bring this to 10? I can just change the bandwidth of that interface. I go to the interface E0 slash, okay, not 2, it's 1. And what is the bandwidth that I need to configure? So I can just make use of this 10,000. By default, it's going to be kilobits. Okay, so if I do question mark here, it says I need to enter the value, and by default, it's going to consider kilobits. So I have changed from 1.5 kilobits to 10,000. Okay, so let's see the routing behavior. So let's see whether I see the 3 routes to be the best path or no. Show IP route. So if you see now, I have 3 best path. Okay, so what has happened is, as soon as I change the bandwidth, this has now become 10. Okay, this no longer 64, and you can see this is how the equal cost load sharing happens. Okay, now what are the things over here? So this is your OSPF AD values, administrative distance, and over here you see the cost value to be 21. So why is 21? So let's do the calculation. So over here it was added up as 10. Over here it again got added up with another 10, so it becomes 20. Now where is the last one? That is the one cost. Okay, that's over here for your loopback interface 10.10.10.1. Okay, so this is 10, 20, 10 plus 10, 20, and then 1 is over here. Now let's verify that. Is it really 1? So let's see that. Okay, I go to Tokyo 30, I say IP OSPF interface loopback 10. Now let's see what is the cost. So cost is 1. So let me tell you, by default in OSPF, for loopback interface type, the cost is considered to be 1. Now this is a standard. Okay, so this is considered to be 1. That's why you can see 10 plus 10 and the other one is over here. Now the same thing applies over here. So this is an egress interface. The 10 gets added up to that packet, OSPF packet. It enters here, no changes. There will be no addition or any impact on those OSPF. Now the OSPF packet that's again existing from this interface will get added up with 10 metrics. Over here it will again get added up with 1, so totally it makes it 21. So that's why you have 3 routes with 21 cost. Okay, so if I go back to my first router, Tokyo R7, if I say I want to see the routes of 10.10.10 dot, so that's 1, right? Okay, so what do I see? I see I have 3 best route. Okay, I have 3 best route, but 1 asterisk mark on one of them. So that says the last packet was being sent over on this way. Okay, the next packet don't have to come back on this. It could be on this direction or it could be on this direction. It's a load sharing. Okay, so as of now, the moment I did show IP route, the packet was being taken up on this path. Which is that path? It's over 0/2, that is over this path. Okay, that's why I got a asterisk mark. Though I have 3 path, I got asterisk on this because the packet was packet traveled on this direction. The next packet can go over on this, and if you do show IP route, you can see the asterisk mark now on this. Okay, and similar thing happen on this. So I can show you that by taking down one of the interface of 29. So let's say I go to conft e0/2, I say shutdown. Okay, so as soon as I make it shut, now let's see. So this has to put that route as down. Okay, so it will take like uh, 40 seconds. In the case of broadcast, it's 40 seconds for the whole timers. So it has lost the neighborship, but on the other side it will take 40 seconds. Okay, so the last 6 seconds left, 3 seconds. Okay, so it should take out, so it has taken down. Okay, now let's see what is the best path preferred. So now you see it's going over on 20.2. now that's this path. Okay, so it doesn't say that it doesn't say that this is the best path or something. It's a resemblance, or it's a notation to show that the moment I triggered this command, the packet was, or the previous packet was on this path. Okay, not on this, or not on the third one. So the asterisk mark says the previous packet was taken up on that path. If you see the show IP route, you will see two paths under this. So let me bring up this. Okay, so the moment I bring this, will also be the part of best route. Fine. So this was with regards to the normal metric calculation. So let's say I have reference bandwidth by bandwidth. Reference 10 to the power 8, and this is nothing but the interface bandwidth. So in my case, it's a Ethernet interface. Okay, 10,000 kbps, which gives me cost value of 10. Okay, now let's change the bandwidth value, and I'll show you there is a drawback with this formula. Okay, so there is some issues with this legacy formula. So issue was with the advancement of the Ethernet technologies. So you saw the technology from Ethernet to fast Ethernet, and from fast to giga, from giga to 10 giga, and so on. Okay, so at some certain point, you will see that this command is gonna have the drawbacks. So to show that example, to show you that as an example, what I'll do is I'll change the bandwidth. Okay, I'll go to Tokyo R10. So let's say, okay, so I can do the changes directly over here. Okay, so let's say I go to conft and the interface that's pointing to the first route, this one, I'll increase the bandwidth to 2 giga or 10 giga. Okay, so let's say I have interface E0/0, 0/1. I say bandwidth now is the maximum one. So let's keep the maximum one, no harm. Okay, I kept the maximum bandwidth. So what should happen now? So let's verify. Do show IP route. So you will see only one path has been taken up now. Okay, the reason is because of the cost value. Now let's see what is the cost it's going to consider. So it's going to consider cost as 1. For the maximum bandwidth, the cost is being taken up as 1. Okay, so what if I change the bandwidth to one less of 0? Okay, I just reduced 1 0. Now let's see what is the cost going to be. It's again 1. Let's change the bandwidth by another 0. Now let's see what is the cost. It's again 1. So let me do one more time. Okay, now basically this is 10,000, which should give me the cost of 10. Okay, So the cost that I got now is 10. So what does it prove? So it says when I have 10,000 kilobits per second, I have the OSPF cost 10. Any faster link above this, which could be giga, 10 giga, the cost value is gonna be 1. Okay. Now this is a drawback with the legacy formulae because all the costs are going to be 1. Okay. So let me show you the exact formula here. Okay. So your till your Ethernet link, the cost is 10. Anything above or equivalent to fast link, the cost value will be 1. Okay. So after fast Ethernet, you have giga Ethernet, you have 10 giga, and so on. Okay. So you are going to have the cost value of 1. So let me do one simple task. Okay. That's I'll have, so let's say I have 3 tasks as of now. Okay. So I'll draw over here. So as of now, they are all Ethernet. And we know by default Ethernet is going to give us 10 cost value. Now how if I change that to fast Ethernet, I change to giga Ethernet, and let's say I make it 10 giga Ethernet. Shouldn't this give me, shouldn't this path should be considered the best path in case of OSPF, right? Because of the better technology. But that's a drawback now. That's a drawback of your, so that's a drawback of your legacy formula. Okay. So let me show you that. Okay, so I have 10,000, which is Ethernet. I'll make it fast Ethernet. Okay. And I'll go to the second interface, which is 0/2. I'll say bandwidth now is giga. I'll add one more 0. I'll go to the last interface, which is 0/3. And I'll add one more 0 to this. Well, so what are the changes I have done? I have fast Ethernet here. I have giga Ethernet, and I have 10 giga Ethernet. Which one should have taken up? It should have taken up this. But you will see, due to the limitation of the formula, all three will have equal cost of 1, and all the three will be considered. Okay. So you can see all the three are considered. What is the cost value? So let's check it out for one of them. Cost value considered is 1. For fast Ethernet, you have 1. For giga also 1. And you have for 10 giga as well 1. Okay. Now that's a drawback. So so how can we overcome this solution? So that's called as auto cost reference bandwidth. Okay. Now this is a advanced topic. When you enable this, make sure you enable across on the route all the routers that is participating under OSPF. Okay. So basically what it does is the mathematical differences in your legacy case. What is the reference that you are considering? You're considering 10 to the power 8. Okay. When you bring up this advanced concept of auto cost, your reference is now 10 to the power 10. So that's a change in terms of numbers. Okay. From 10 to the power 8, now you are considering 10 to the power 10 reference bandwidth. And that will make a lot of changes now. Okay. So let me show you what happens. Okay. So I'll go back to the interface and I'll bring up the concept of auto reference. Okay. I'll go to router OSPF1. I'll say auto cost reference bandwidth. What is the bandwidth reference that I need to consider? So megabits per second. Okay. So let's give it as 1000. So what is 1000 megabits per second? Let's check it out. Okay, so this is the value. Now we are going to consider. I press enter. So it says reference bandwidth is changed. Please ensure reference bandwidth is consistent across all routers. That's a best practice. Okay, whenever you do a change, make sure you do it across on all the OSPF routers. Okay, fine. So I've done on all of them. So let's see the routing table. So I have two routes now. Okay, let's see the values now, cost values. So this is taken as 10. Earlier it was considered as 1, but now it's considered as 10. The fast Ethernet now gets the value of 10. Okay. So in the legacy calculation, fast Ethernet was also having 1. Okay. But in the advanced calculation, which is auto reference, now fast Ethernet gets a value of 10. Okay, now let's check out the high speed links, which is 2, which has taken up cost value of 1, and the 10 gig, which is also taking up cost value of 1. Okay, so the faster link, or the giga links, will take the cost value of 1. This fast Ethernet is now been the property of fast Ethernet has been changed. Okay, so that's how we have the cost formulae for a legacy and for a advanced one. So when you deal with the giga Ethernet, make use of auto reference. If you're still with your fast Ethernet and Ethernet, then the legacy is all good enough. Okay, so that's about the cost value. I have few smaller topics which we discussed earlier as well. So one of them is summarization of routes. Okay, now what is summarization? So let's say I have a router where I have multiple networks inside my routing table, like 172.1.16.0, 172 1.17.0, 172.1.18.0, slash 24 slash 24 slash 24. Now there are multiple networks inside my routing table. So what I can do is I can make use of summarization. Okay, one single command, that is this command, okay, which says area, whatever area you want to summarize, make use of the word range. This is used for summarization. Okay, and the network that you are going to summarize. So in this case, I'll make use of 172.1.0.0. What would be the wildcard mask? So this is the subnet mask, and what is the area that I'm going to use? This one. So the moment I do this, my networks are going to get summarized. So let's see if I have any routes here which I can summarize. Okay, I have 10, 20, but they are locally. I have 30. I have 50 and 60. Okay, let me give a try on this. Okay, so I go to conft. So if you see, there are multiple lines for 192. Agree? So let's give a try summarizing that so that I can minimize my routing entries. So I go to router OSPF1. I say area. Which area am I dealing with? I think it's area 100, right? So it's area 100. I make use of range command. What is the IP that I want to summarize? So let's summarize this. Okay. Whether it's using wildcard mask or subnet mask, so it's using subnet mask. So I'll make use of this IP. And what is the cost? So I need to define the cost. Okay. So because when they are individually, they are going to consider some cost value. If I don't, in case now I'm summarizing, I have to manually define. So let me define the cost value. So I say cost value is 101. So let's give it a try now. Okay, so you need to do this on the ABRs. Okay, so your ABR is going to summarize. So this happens when this router act as a ABR. But as of now, this is not ABR because we are only dealing with one area. So let me show you over here this router. So let's open up Mumbai 4. So let me see what are the routes I have. So I have 172. So I don't have any routes. So let me give a try with this routes. Okay. So let's go with conft router do show run session OSPF. So I have OSPF process 1. I say area 0. I say range. What is the network that has to map? What is the subnet mask? What is the cost value? So what is the cost it's reading? It's reading 20. So basically there are only one network, so you will not see much difference here. So we need multiple networks so that it can summarize into a broader network. So if you see the output is same as before, 16.23 and 16.23. So basically you need 16.24, 16.25, which will summarize to a broader network. That's a summarization which is similar in OSPF also. Okay, it's the purpose of summarization is to reduce the routing base entries. Okay, instead of having so many routing entries, we can just summarize to a broader network. Okay, so I have few more topics. I guess we will do it in the next class. Okay, so guys, if you have Q&A, do let me know. Okay, so regarding this, as I told you, whatever I did today is not something which I did for the first time. It was already done in the class 1 and class 2. Okay, So just let me make use of a notepad to tell you how do we write or bring a OSPF process. Okay, so let's say I take a console of R1, I go to conf t. Let's say I go to the first interface E0/0. I define the IP address here. Let's say 1.1.1 I make it no shutdown. Now I go and enable OSPF process, and then I can advertise this network by 1.1.1.0, and then I'll make use of the wildcard mask, and then I'll define area. Okay, so this is the command which I do before the class, because I don't want to do this on all so many routers. So you know how much time it would take in case I have to configure interface and OSPF on all these routers. It will take easily 30 minutes. So that's going to be extending the whole class duration. Okay, so this is something which is defined in the workbook as well. So if you open up the workbook, you can see this configuration which is under the initial configuration, uh, which we are going to use lab by lab. Okay, so these things will not be done again and again on every classes. It is done on one time, which is a part of initial configuration, and then we just try to bring up some new concept like stub or non-so stub or passive. So these are all done on theoretical basis. Okay, if I have something theory for this, I'll do this, which is not going to get saved. Okay, so these are going to get saved because these are a generic command lines for getting up the OSPF process. Okay, so these one will be taken up in individually classes, like how in the class today, when it was about stub, I showed you how do we configure stub, how do we configure non-so stub, and similar way the cost manipulations. So those are done topics by topics. Okay, whereas these are once done and once saved on these devices. So I don't do it before the classes. They are already within this routers. They are called as initial configurations. Okay, I did these interface and OSPF process on the day number one, while showing you the OSPF. Okay, and then I save those configuration, those default configuration. That is why when I power them on, these configuration will be still lying down there. So I also suggest you guys. So hope I'm audible. So I also suggest you guys, whenever you're practicing routing, don't try to do the interface and the process every and each time. Okay, so try to keep them saved. How do you save them? So let's say when I open up the console, when I have configured interface and I have the OSPF, I go and make use of this command. So while doing this, my the initial commands will initial configuration command will be put up under startup config. Now whenever I reboot, this startup config will be pulled up. Okay, so that's how my interface, all those things comes up. So I was not trying to be faster, or I was not trying to not show you guys the interface, but I assumed that I have done already in the previous classes, so I just bypassed those steps. Okay, okay. Type 5 and type 7, why would one opt to do the other over the other? Okay, so basically it's when you want to suppress all your external routes. Okay, now let's say in my scenario there were like only 2 3 routes. When you have couple of routes like 10 20 routes, so you will see a lot of LSA 5 packets. For each network there will be a individual LSA type 5 packet which would be increasing the overhead on these routers. So what I do is I bring up non-so stubby so that these are removed off. So these gets removed off, and we have guys be on mute. So these LSA 5 gets removed off or replaced by the 7. Okay. How to advertise loopback as slash 20 slash 32. Now this is happening by default. You don't have to do anything. Okay. You should have asked how do we advertise it in slash 24. Let me show you. By default, loopbacks will advertise on slash 32. So if you see here, all my loopbacks are getting advertised by default on slash 32. Wherever you see slash 32, that is a loopback address. Okay, these are the networks. That's why they're getting advertised with whatever we are advertising it. Okay, we are advertising slash 24, so we see slash 24. But in the case of loopback, even though I'm advertising on slash 24, I see it to be slash 32. Now that's a default behavior, and I remember I told you about this. So by default, OSPF treat a loopback as end host. So usually end host are on slash 32. That's the reason when you have a loopback interface with 1.1.0 slash 24, your OSPF will still consider it as a end host, and it would advertise just on slash 32. Now you can change this behavior by changing the OSPF network type from broadcast to point to point. So when you do this, the slash 32 will be reverted back to slash 24. Okay, so by doing that, you can still advertise loopback on slash 24. But in the case of broadcast, loopback is considered to be end host, and end host are slash 32. Okay, regarding the meeting link, I would say that always see the WhatsApp group description. Okay, so you will see the group description, you will have the Zoom ID, or else or otherwise, every time when I begin up the class, when I took the class today, I have put up the Zoom ID manually on the group chats. So you have not seen either this neither this, so that's why you have missed the class. But don't worry, you will get the recording as soon as I'll upload today. So any other doubt? I know the previous class is still not been loaded up. I will do it now. Okay, Notepad plus plus. So what do I have in Notepad plus plus? So basically, Notepad plus plus is only for my reference, and then I copy paste those into the workbooks or the documents, because my Notepad plus plus might be you guys will not understand. See, for example, this one. So let me tell you my way of writing the configurations. Okay, so I say, for example, I have, let's say I'm writing up one of the BGP topology. Okay, I keep my topology next to me. I'll bring up over here. Okay, if I press F11, okay, it's not taking now, but if I type F11, this is going to be permanently placed at this position. Okay, it's not going to be going backward for any reason. Now what happens? I start writing up my configuration. I don't go to the CLI individually. I know the commands by heart, right? So let's say I'm going up to the first router like Tokyo R18. I see which is that interface. I say interface E0/0. I say IP address, that's 192.168.23.12.255.255.255.0. No shutdown. I'll go to the next interface which I see over on the screen. I say IP address 192.168.2.1.255.255.255.0. No shutdown. I say I need BGP now. Router BGP. What is the AS value? What is the neighbor that I want to advertise? Let's say I want to advertise this. What is the autonomous system? So let's say it's advertising on this. So this is how I write the configuration. I don't go on each of the boxes, write individually. Okay. So that is why I'm not sure my Notepad plus plus is of any use to you guys, because you are not going to get what I've written here. So you will see a lot of junks values. Okay, but yes, if you can, then I have no issues giving you this uh, these nodes. Okay, so what I do is once I have all the configuration, then I bring up these workbooks. I write them in a format like so that you guys can understand. So okay, let me quickly tell you what are those initial config that I was talking about. Okay, which I have not done today, and you guys thought I am faster or I don't go step by step. Okay, so this is the one which I was talking about. Prepare the initial config. Now what is that config talking about? It's about writing those interfaces and bringing up the loop back, so you can see all the initial configuration device by device. Okay, and then you have the OSPF configurations, and then I have saved it. After this I have saved it. So now every time when I bring up these routers, I don't have to do these configuration again and again. I can go straight to the stub, or I can go straight to the virtual link, and I can practice my labs rather than spending time 30 to 40 minutes on these initial configurations. Okay, fine. So any doubt or any question on taking these things in a better way? So I would recommend write the configurations by seeing the topology. If you open up each console and then you type, you will basically will not save the configuration. So what happens next time when you boot your router, you have to redo the configuration. So make use of Notepad, write them roughly, execute, and whatever initial configuration, just save it, like interface configuration or the OSPF. Because in my topology, what the speciality is, let's say I have OSPF here, I would not use any other technology later on. So it's better I keep those initial configuration always. Or let's say I am configuring some other technology in the later on stage. Let's say I am configuring BGP, but that's not going to override, or that's not going to uh, block my initial configuration, right? Even the BGP will require this initial IP address assignment, right? So that's actually simplifying your own task. So make use of that way, so that you can cut down few of the timings on the initial configurations. Okay, so any other doubts? Okay, so this I have already told. Yes, you can do with EVNG, but on EVNG you don't have the appropriate containers. Okay, so basically on GNS you have some containers. So these containers you will not find on EVNG. The rest other things you have, you will get the EVNG topology from us. But these are not being assigned to those EVNG. Okay, so your EVNG cannot have these containers. These are only for GNS. So it's up to you if you want to sacrifice these topics like network automation, syslog, DNS, AAA. Then yes, you can go with EVNG. I can provide you the topology. You can practice the other things on EVNG. Yes, but we can use containers EVNG Pro. If you have EVNG Pro, then you can make use of this. So you can give it a try if you can uh, practice these containers. But I'm not sure if every one of you have these EVNG Pro. From our side, we have the EVNG topology, which we can give it to you guys. Now it's up to you how you gonna fix this containers there. I know they have the latest version, which is called as Docker inside Docker, which says that we can bring up any Docker or any Docker within another Docker. But I'm not sure how effective are they. Yeah, you can get the EVNG version. You can get the EVNG version. In fact, we have given the EVNG version to one or two student already. Yeah, we have already distributed the EVNG topology, but excluding these containers. Okay, so excluding these containers, we have given the rest of them. So if you have the pro version, you can check it out to get these containers. Okay, okay, I can send you. I will send you after the class, so you will get the EVNG version. Okay, guys. So let's meet up in the. Okay. So did I close the chat? Okay, fine. So I will put up on the WhatsApp chat. Okay, and I'm also going to unblock the comments on the WhatsApp chat. The reason why they were disabled is if I put up some important message, that's gonna get unnoticed. Okay, so because students are from various zones, so someone who wakes up in the morning will not be able to see those important messages. So that's why I had blocked it. Okay, so I wanted to bring some other forum for discussion where you guys could have discussed and all those things. But yes, it's fine. We have covered a lot of topics now, so I'll unblock those features so you guys can chat over the WhatsApp directly. Okay, so that's all from my side. We will meet up in the next class and have a nice day. See you all. Take care.